All right, so today we're going to be talking about balancing chemical reactions and its structure. So, chemical reactions occur when substances go through chemical changes to form a new substance. And this means that, so remember Chem A when you learned about chemical changes, well, we're going to dive more in depth of those. What do they look like? Why are they changing to new substances and how they're doing it? A reaction can include atoms, ions, compounds, or molecules of a single atom. Also, bonds between atoms are broken and created to form new molecules. Now, chemical reactions always and must occur. They occur and right before our eyes all the time. Now, there are four signs that a reaction has occurred. One is a formation of a gas, which means it's bubbles. If you see bubbles, there's a reaction happening. Two is a formation of precipitate, meaning that there's a solid that's being formed. Three is release of energy, so if there's a massive temperature change. And four, a change in color. Now, chemical reactions have specific structures. Now, looking here at this image, we have compounds or elements on the left side of this arrow and compounds and elements on the right side of the arrow. Now, anything to the left side of the arrow we like to call reactants. Anything to the right of the arrow we would call products. Now, this arrow is called a yield sign, and all of these plus signs, we all know from math, it's an addition sign. Okay, so that means that compound element 1 plus compound element 2 yields compound element 1 plus compound element 2. That's kind of like how that goes. Now, chemical reactions must follow the law of conservation of mass. And that law states that in an ordinary chemical reaction, matter is neither created nor destroyed. In lame terms, there's neither gain nor loss of any atoms during the reaction. So these number of atoms need to be equal, the same throughout the reaction. Now, when you write an equation for the chemical reactions, the two sides of the equation, so the reactant side and the product side, should be balanced. Now, this means you need the same number of each atom on both sides, which helps the reaction to follow that law of conservation of mass. Now, there are steps for balancing this chemical reaction, so they obey that law. First is you're going to box the polyatomic ions that are present on both sides of the reactions. Now, on the second page of the periodic table I posted on the classroom, it includes all the list of the polyatomic ions, so just refer to those. Two is you're going to list each atom present on both sides of the reaction. Now note, keep the polyatomic ions together if present on both sides. So any polyatomic ions you boxed, just rewrite those when you list out the atoms. Don't split them up. Three is you're going to identify the number of each atom that is present on both sides of the reaction. And four, you're going to choose coefficients that will balance the numbers from step 3. Now, a number in front of a compound or element in a reaction are called coefficients. And you multiply your coefficients to all the subscripts in the compound. Now note, you're going to leave the HOs for last. Now HOs meaning hydrogen and oxygen for last when you balance. So when you list them out and when you balance them, always keep them to the last because 9 times out of 10, they will balance itself out when you balance all the other atoms first. So let's go ahead and do some examples of balancing chemical reactions. So this chemical reaction we have right now is we have Mg plus O2 yields MgO. The very first thing I like to do is to box your polyatomic ions. But in this reaction, I don't see any polyatomic ions. So we're going to skip that step and move on to listing out all the atoms we have. The way I like to do this is I first want to divide this reaction with a line. I want to split the reactants and the products, okay? So in our reactant side, the following atoms we have magnesium, and we have oxygen. Then on the product side, we also have magnesium and oxygen. Now, if you are doing this correctly, both of these should be the same atoms listed, okay? Next is we got to determine how many of atoms do we have for each. So looking on the reactant side, we have 1 magnesium. And looking at the reactant side for oxygen, we have 2. So we have 2 oxygens. Now looking at our product side, mg's. Well, we have 1 mg. And then how many O2s? How many oxygens? Well, we have 1 oxygen. Okay. And now we got to go ahead and balance these numbers out. Okay? So magnesium should have the same number and oxygen should have the same number. So looking at magnesium, we have 1 and 1. Well, that's the same. So magnesium is good. So we'll go now to do our oxygens. We have 2 oxygens and 1 oxygens. Well, they're not the same. So, is there a whole number that we can multiply 2 to get 1? No, there isn't. But is there a whole number to multiply 1 to get 2? Well, yeah, that's 2. So, if we multiply 2 to the 1, we will get 2. So that multiplying 2, that 2 will be a coefficient going in front of mg. And that tells me that now we have 1 oxygen, but we multiply by that 2, so now we have 2 oxygens. But this coefficient applies to everything in the compound. We not only have oxygen, we also have magnesium. We have 1 magnesium, but we have a 2 in front of us, so we have to multiply. So 2 times 1, now we have 2 magnesiums. Is our oxygens balanced now? Yep, we got 2 and 2, so they're good. But is our magnesium still balanced? No, we have 1 here and 2 here now. Now we got to balance this out. Is there a whole number I can multiply to 1 to get 2? Yeah. What number is that? That's 2. I can multiply 2 to 1 to get 2. So that 2 is a coefficient. We want to change magnesium. We have an option to put in front of Mg or in front of O2. Well, we want to put in front of Mg because we want to change Mg. If we put it in front of O2, that changes O2 and makes it unbalanced again. So we had originally 1 magnesium, now we have a 2 in front of it, so 2 times 1 is 2. Is our magnesiums balanced? Yeah, because we have 2 and 2. And is our oxygen balanced? Yes, we have 2 and 2. So this right here is your final answer with those 2 subscripts. Now, yes, O2 does not need a coefficient, and that's okay. Not every compound in your reaction will have a coefficient. But we don't write 1s as coefficient, so really there is a 1 in front of O2. So in your homework, when you don't have any coefficient in front of it, you're going to type out just 1. Okay? And that's it. Okay, so let's go ahead and do another example. This time I have FeS plus HCl yields H2S plus FeSCl. Okay, first step is we got to box our polyatomic ions. Well, in this particular reaction, I don't see any polyatomic ions, so we can go ahead and skip that step. Our next step is to list out all the atoms present on your product side and on your reactant side. So let's go ahead and do that. Remember, I like to divide this reaction in half. All right, so let's go ahead and figure out all the atoms that are on our reactant side. Well, we have Fe, we have S, we have Cl, and we have H. Now remember, we were going to leave the host for last. We're going to leave hydrogen and oxygen for last. That's why I listed hydrogen out very last. It's just because you're going to just go down the line. Okay. All right. Now looking at our product side, let's figure out what atoms we have on our product side. Well, it looks like we also have Fe on this side. We also have S, Cl, and H. No more, no less than that. Remember, if you're doing it correctly, these should be the same. Okay. Now next we got to figure out how many of each of these atoms we have on our reactant side and have on our product side. So, let's figure out how many irons we have on our product side. Well, we have 1. How many sulfurs? We got 1. How many chlorines? We have 1. How many hydrogens? We have 1. Let's go ahead and look at our product side now. We have 1 for iron, 1 for sulfur, 1 for chlorine, and this time we got 2 for hydrogens. So now we got to go ahead and balance these out. So balance these numbers out. And all we do is just go down the line. So is our irons balanced? Yes. Is our sulfurs balanced? Yeah. Is our chlorines balanced? Yep. And is our hydrogens balanced? No, hydrogen is not balanced. And I made a mistake on our reaction. This is actually supposed to be FeCl2, so we don't have 1 chlorine, we have 2 chlorines. That is my bad. That is my bad. All right, so going back. Is our irons balanced? Yes. Is our sulfurs balanced? Yes. Is our chlorine balanced? No, right? Because 1 and 2 are not the same. Is there a whole number I can multiply 1 to get 2? Yes. And what is that whole number? 2. So 2 is going to be our coefficient. Now we want to balance out our chlorines. So which compound has chlorine in it? Our first one or our second one? Well, our second one does. So that 2 goes in front of that compound. Okay. So now we had 1 chlorine. 2 times 1 is, now we have 2 chlorines. But it also changes another element. What other element is in this compound? Hydrogen. So we had 1 hydrogen multiplied by 2, so now we have 2 hydrogens as well. So is our chlorines balanced now? Yes. Is our hydrogen balanced? Yes. And that's it. Okay, so let's go ahead and do another example. Now this one, we have PbNO3 plus Ki yields to KNO3 plus PbI2. Now our first step for balancing is we got to box our polyatomic ions if they are present on both sides. Well, looking at this reaction, I see polyatomic ions. I see NO3, and that's nitrate. Is NO3 also in our product side? Yes, so let's go ahead and box it. Because we know that polyatomic ions cannot be broken up. So the box will help us determine, hey, I can't break it up, they're 1 unit. Now next is we got to go ahead and list what atoms are present on our reactant side and what atoms are present on our product side. And remember, I go ahead and divide our reaction in half. And let's go ahead and list all the atoms out that are on our product side. We have Pb, we have NO3. Remember, we don't want to break it up, so we're just going to list out NO3 out. Okay, we don't want to break it up. It's 1 unit. We got K, and then we have I. Okay. And let's go ahead and do the same for our product side. Well, it looks like we have pretty much all the same on our product side. So we have Pb, remember, don't want to split up our polyatomic ions, so just rewrite it, Rk, and Ri. So let's go ahead, next is we got to determine how many of these atoms are present on the reactant side and our product side. So looking at Pb, we have one Pb in our reactant side. We have two NO3s. We have one K, and we have one I. Let's go ahead and do this one here. We have one Pb. We do not have a number outside of our box, so we know that we only have one NO3s, one K, and we have two I's. Okay. And now we got to go ahead and balance those numbers out. So just go down the line. Is our PBs balanced? Yep. Is our NO3 balanced? No, because we got 2 and 1. So is there a whole number I can multiply 2 to get 1? No. Is there a whole number I can multiply 1 to get 2? Yes. And what is it? It's 2. So our 2 is going to be our coefficient. If we need to change NO3, which compound has NO3 in it? Is it our first one or our second one? It's our first one. So that 2 goes in front of KNO3. Now we have 1 NO3s. Now we multiply that 1 times 2. So now we have 2 NO3s. But wait, is there another element in that compound? Yes, it's potassium. So potassium also has to change. We had 1 potassium, so 1 times 2 is 2. So we also have 2 potassiums as well. Is our NO3s balanced now? Yes, we got 2 and 2. Is our potassiums balanced? Not anymore. We got 1 and 2. That's not the same. Is there a whole number I can multiply to 1 to get to 2? Yes, and what is it? It's coefficient of 2. So we got to put that coefficient in front of a compound that has potassium in it. Does our first compound have potassium in it? No. Does our second one does? Yes. So that 2 is going to go in front of Ki. We had 1 potassium times 2, which is our coefficient. So 1 times 2, now we have 2 potassiums. But there's also another atom in that compound, and that's iodine. That's I. So we have to change I as well. We had 1, coefficient of 2, so 2 times 1 is 2. Is our potassiums balanced now? Yep, we got 2 and 2. And is our iodines balanced now? Yep, 2 and 2. So is everything balanced? Yep, so that is your final answer. I'm going to do one more example before I have you do some on your own. Now this one we have C7H16 plus O2 yields CO2 plus H2O. Now first we got to box any polyatomics that are present on both sides. But in this one I really don't see any polyatomic ions. So we're going to skip that first step. Now our second step is we got to list all the atoms present on both sides. So remember, we always just want to separate our reaction in half. So our reactant side, we have carbon, hydrogen, and oxygen. Remember, if you have oxygen and hydrogen by itself, just list it out at the very end because we know we want to keep those for last. And then on here, we also have the same ones on our product side. Yes, we have oxygen in 2 compounds, but you do not need to list oxygen twice. Okay. Now we got to figure out how many of these atoms we have on each side. So looking at our reactant side, we have 7 carbons. We have 16 hydrogens, and we have 2 oxygens. Now on our product side, we have 1 carbon,
2 hydrogens and our oxygens. Now, we have 2 oxygens on our carbon side and 1 oxygen on our hydrogen side. We got to take the sum of them, right? We said we have 2 of them here. Oops, that's not working. So we have 2 on our oxygen side and 1 here. So 2 plus 1 is 3. Let's go ahead and start balancing out these numbers, and we'll just kind of go down the line. So carbons, is our carbons balanced? No. Is there a whole number I can multiply to 7 to get 1? No. But is there a whole number I can multiply 1 to get 7? What is it? 7. So 7 is going to be our coefficient. We need to figure out which one of these compounds have carbon. Is it compound A or compound B? It's compound A, so we have to put the 7 in front of the CO2. So we had 1 carbon times 7, so now we have 7. But does it change something else? Yes, it also changes that oxygen. Well, we have 2 oxygens, so 2 times 7 is 14. So now we have 14. So we have 14 here, 1 here. So now we don't have 3 anymore. We have 15 oxygens now. Okay. So let's go ahead and go down the line. We got our carbons balanced, 7, 7. Now is our hydrogen balanced? No. Is there a whole number I can multiply to 16 to get 2? No. But is there a whole number I can multiply 2 to get 16? Yes. And that number would be 8. So 8 would be our coefficient. We need to change hydrogen. So is there a hydrogen in compound A or compound B? Compound B. So that coefficient of 8 goes in front of H2O. We have 2 hydrogens, so 2 times 8 is 16. But wait, it also changes our oxygen because we have oxygen in that compound as well. Well, we have 1 oxygen, so 1 times 8 is 8. And 8 plus the 14 from the CO2 is, if we do math, what, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now we have 22 oxygens total. So our hydrogens are balanced now, so let's go ahead and move down to oxygen. They're not balanced at all. Is there a whole number I can multiply 2 to get 22? Yes, and that's 11. So 11 will be our coefficient. We are changing our oxygen. So we had to figure out which compound has oxygen, compound A or compound B. Compound B, so our 11 will go in front of O2. 11 times 2 is 22. And they're balanced. So everything's balanced, and that's your answer.
Okay, go ahead and balance this chemical reactions. N2 plus H2 yields an NH3. And here's your answer. Okay, so go ahead and try balancing this chemical reaction. We got Cu plus AgNO3 yields CuNO32 plus Ag. And here's your answer. All right, so one last thing that we need to know is in balancing chemical reactions, compounds react in a set ratio. And those ratio numbers are your coefficients, those big numbers in front of the compounds that we put on to make sure they're balanced. Now these ratios, again, are the coefficients in the reaction, and these ratios are specifically called mole ratios. Okay, so let's go ahead and do an example. Now we have 2 Mg plus O2 yields 2 MgO. Now the mole ratio between Mg to O2 is 2 to 1 because Mg has a coefficient of 2, so that's where that 2 comes from, and O2 has a coefficient of 1, right? If there's no coefficient, that's 1. So that's why it's 2 to 1. Now the mole ratio between Mg to MgO is 2 to 2. Mg has a coefficient of 2, MgO has a coefficient of 2, so it's 2 to 2. And the mole ratio of MgO to O2 is 2 to 1 because MgO has a coefficient of 2 and O2 has a coefficient of 1, so that's why it's 2 to 1. So go ahead and find the mole ratio of each of these, of MgO to Mg, Mg to O2, and O2 to Mg. And here's your answer. We got 2 to 2, 2 to 1, and 1 to 2. And that's it. Thanks, guys.